Today we're going to be taking notes over section 6.1 through 6.4. This is 4 sections that we covered before Christmas break, and you're going to be tested over this or quizzed over it 1 week from today. So I wanted to do a bit of a review to make sure that you still understood and remembered some of the things we talked about before Christmas. So first up, section 1 says to write the percent as a decimal. Looking at this first one, 57%, where's the decimal point at? Behind the 7, okay? What do I have to do with that decimal point? Move it to the left, so what's my answer?
0.57.
0.57. I want you guys to go ahead and do the next one on your own. Okay, let's see how you did. Where's the decimal point at in 624%? After the 4, bring it over. What's your answer, guys?
6.24.
6.24. How many of you got that? Good job. For number 2, we're basically doing the opposite. This asks us to write the decimal as a percent. What should I do with my decimal point? Move it to the right 2 times. Okay, and then we'll add a percent sign. So what does 0.09 become? 9%. Next one, Joseph, what should I do?
Move it to the right twice.
And what's your answer?
632%.
632% is the same thing as 6.32. Number 3, write the fraction as a decimal and as a percent. If you remember, this fraction bar means what? Add, subtract, multiply, or divide? Divide. So we're going to take the top number and divide it by the bottom number. So you're just putting in 2 divided by 5. Guys, what's 2 divided by 5? 0.4. Now, in order to turn that into a percent, I've got to move this over
2 times.
Okay, and what do I get? 40%. So what this is asking me is write it as a decimal. We know 0.4 was our decimal, comma, to separate it, and the percent was 40%. All right, let me have you and your partner go ahead and do problem B together. All right, so 9/100ths we know means 0.09, and we've got to move that over. So what would that be as a percent? 9% is correct. How many of you guys got that same thing? All right, if you did not, just go ahead and erase it and fix it for me. You guys can hop back into your seats. All right, so for this next one, there's 2 formulas for number 4 and 5 that I want you to remember. What's the percent proportion and what's the percent equation? If you don't know it, I want you guys to pull out your notes that we took and go ahead and fill those 2 in. All right, let's see what we came up with. Guys, what's the percent proportion? All right, that makes sense because if you remember, a proportion is 2 fractions that equal each other, which is exactly what that is. Next up, what's the percent equation?
P times of equals is.
P times of equals is. Very good. And if you remember, we're talking about the part and the whole. The is will always be your part, and then your of will always be the whole. Okay, so these are 2 formulas that you're going to want to have memorized for your quiz 1 week from today. For the next section, number 6, this is asking us just to use the percent proportion to solve. So remind me again, guys, what's the percent proportion formula?
Is over of then equals P over of.
Very good. So every time we're going to go ahead and start off with our formula. Now, if you remember, we talked about how to separate this original problem up here into 3 different sections, the is, the of, and the p. So the first thing you can see here that we've got is what percent, that's my p, then this is going to be my of, and this is my is. Now remember, that's just a simple way that we can separate finding the is, of, and p. Austin, help me plug these things in. What's my is?
20.
What's my of?
50.
What's my p?
X.
Okay, since we don't know it yet, we're actually going to keep it as a p because that'll remind us that we need to turn it into a percent at the end. Now, there is a way that I could actually use mental math to figure out. I want to know what that p is, so I'm trying to work from getting the 20 to the p. How do I get from a 50 to a 100? Times 2. So mental math tells me I can multiply by 2 on the bottom, multiply by 2 on the top. So right here, 50 times 2 equals 100. If I do this up top, 20 times 2 equals 40. And remember, it says P, so I'm going to have it be a percent, so that just means 40%. So the final answer, 40%. Looking at problem B, let's go ahead and separate it into 3 different parts. What's the first part I should underline?
What number is?
What number is? What should I circle?
36%
Very good. And underline?
of 85.
Very good. Okay. What is my percent proportion? Just the boys.
X.
What's the formula for percent?
Oh, I was doing something else, my bad.
What's the proportion? It should be 2 fractions that equal each other. Is over of equals P over 100. Zario, what's my is? We don't know it, so we're just going to keep it as an X. What's the of?
85.
85, good job. And then P is what?
36.
Okay, 36%, which means 36 over 100. Now, can I do mental math on this one? No, mental math doesn't really make sense because there's not a clear missing link between the 100 and the 85. So instead, what should I use? Which method? Cross products. All right, Kalani, what do I do for cross products? Okay, very good. 100x equals 85 times 36. And what is 85 times 36? Very good, 3060. Now remember, your whole goal is to get the x by itself. Kalani, how do I do that? Good job. What we do to one side, class? You got to be fair and do it to the other. What's my final answer?
30.6.
30.6. Next one looks very similar to number 6, but these instructions ask us not to use the percent proportion, but to use the percent equation. Guys, what is the percent equation?
P times of equals is.
P times of equals is. Noah, help me to circle and underline the original problem.
You underline what percent, circle of 50, and underline is.
Good job. What's my P?
We don't have it.
We don't know it yet. What's my of? And what's my is? How do I get P by itself?
Divide 50.
Okay, we're going to divide by 50 on both sides. This cancels out. What's 20 divided by 50, class?
0.4.
Okay, 0.4. Dominic, how do I turn that into a percent?
Move the decimal over to the right twice.
And what's your answer?
40%.
40%. Now listen, I want you guys to go back to 6A. That was on the front page. I asked the same question there. I said, what percent of 50 is 20? But we found it with the percent proportion. What answer did you get on 6A?
40.
40%. What did we get on 7A? 40%. The only difference is it asked you to do it 2 separate ways. Does that make sense? Okay, so I want you guys to go ahead and do this next one. What number is 36% of 85? If you look at 6B, what was the answer on 6B, the front of our paper? 30.6. So hopefully you're going to get that same thing. Go ahead and do it with your partner. Start off with writing what the percent equation is. Remind me again, guys, what's the percent equation?
P times of equals is.
Very good. Okay, so do it with your partner, please. All right, as we look at this, we want to go ahead and separate the original problem into 3 parts. The first one is what number is 36% and of 85. A lot of you forgot to do this one teeny tiny step. The P, I'm not going to put it in as 36%. I have to change it to a decimal. So what will the P be?
0.36.
0.36. Do I know my of?
85. Yes.
85. Do I know my is?
No.
No. Okay. Guys, what's 0.36 times 85?
30.6.
30.6 is my is. Did anyone get that? All right, a few of you. Good job. The main thing I saw as I walked around is people just forgot to change that percent to a decimal. Now, if you look back at the very front page, look at 6A or 6B. It asks the same question. What number is 36% of 85? We got 30.6 on that one by doing the percent proportion. We should get the same answer while doing the percent equation. So that just kind of shows you that I've taught you two separate methods to come up with the same answer, okay? So for this next one, modeling real life, I do not care whether you use the percent equation or the percent proportion. Work with your partner to try to figure out these two, but just remember, whenever you have the of and the is, which one is the part and which one is the whole? You guys know? The of is always going to be the whole amount. The is always going to be the part. So use that to help you as you're plugging in your is and your of. So how many of you would say that you use the percent equation? Okay, if you use the percent equation, you did P times of equals is. We're looking for the P. We don't know the percentage yet. Do we know the whole amount of 7th grade students that are there? How many?
95.
There were 95. That's my whole. And then the part that it's talking about are how many of them play sports. So that's 38. In order to get that P by itself, you just divide by 95 on both sides. And when you do that, you should have got 0.4. And remember, you want to change it to a percent. So what's the answer, guys?
40%.
40%. How many of you would say you and your partner both got that answer? Okay. Who has a question for me if that doesn't make sense? All right, once again, if you did the percent proportion, is over of equals P over 100. The part that we were talking about was 38 students that play sports. The whole amount of 7th graders was 95 equals P over 100. For this one, if you did it this way, how many of you would say you did cross products? Okay, so for that you would have 38 times 100 equals 95p. What's 38 times 100, guys? 3,800. And then you want to get p by itself. What do you get when you do this?
40.
Okay, and then you remind yourself you've got to put the percent. So notice, it doesn't matter which way you find the answer. Both answers should have helped you to figure out 40% of the students play sports. What is the percent of change formula? Does anyone happen to remember percent of change formula? Maddie, what'd you get?
P equals AOC over original.
Okay, AOC over original. Who remembers what AOC means?
Amount of increase or decrease.
Okay, it is the amount of increase or decrease. That means the amount of, what was it, Kalani? Amount of change. Good job. Okay, so in order to find the percent of change, you do the amount of change divided by the original amount. So for number 10, we're going to use that formula to help us. It says find the percent of change as an increase or a decrease and then always round to the nearest tenth. So we're going to start off with our formula. Remind me again, guys, what is that formula?
ADC over.
Okay, it's the amount of change over the original amount. So let's just kind of talk about this. Let's imagine that this was a tree that got planted. It started off at the beginning of the year at 24 inches, and it grew to the end of the year to be 78 inches. Did that tree increase in size or did it decrease in size? It increased, okay? So in the end, we're going to know this was an increase. How do I find how much it increased? If it was 24 and it got to be 78, how do I figure out how much it changed? I don't want to divide it yet. How do I find that amount of change, how much it grew? Christian? I'm not going to multiply. Maddie? I am going to subtract it. Okay, so let's take our bigger number, which was 78, and we're going to subtract 24. That will help me to see how much it grew. Then I divide it by how much it was originally. How tall was it when it originally started? 24 inches. Okay, so now, guys, what's 78 minus 24? 54 divided by 24. Who can help me? What is 54 divided by 24?
2.25.
All right, 2.25. Now, if you remember, I want to find this as a percentage. So what should I do with my decimal?
Move it over to the right 2 times.
Good job. So what would this be?
225%.
225%. Now, once again, go back to this. It started at 24 inches and it grew to be 78 inches. Did it increase in size or decrease in size? It increased in size. So my answer is 225% increase. All right, so let's imagine that at our school in class, we started off with 22 people. But by the end of our class period, we only had 18 people in it. Maybe they had to leave for a doctor's appointment or dentist or something. So is this an increase of people that came to class or a decrease? It's a decrease. I started with 22 and I ended up with 18. So let's start. This is going to be the amount of change over the original amount. How do I find the amount of change? If I had 22 people and now I only have 18 people. You subtract it. 22 minus 18. Over the original amount, how many people came to class at the beginning of the class period? 22. All right, finish this up with your partner. Make sure you round to the nearest tenths place. Okay, so first up, the amount of change is 22 minus 18. So the amount of change is simply 4 people different from the beginning of class to the end of class. And I've got to divide that by 22. When I do that, I get 0.18 repeating. So 0.18181818. It could go on and on forever. All right? To turn that into a percent, what do I do with my decimal point? Move it 2 places over. So now I basically have 18.1818181818%. In the instructions, it asked you to round to the nearest what? Tenth. What number right there is in my tenths place?
8.
The number directly after the decimal point. So this one simply asks his neighbor, is it 5 or bigger? Is an 8 5 or bigger? Yes. So what happens to my tenths place? It bumps up and it becomes a 2. So the answer now is 18.2%. I had 22 people, but we know that we didn't end up with that. We started with 22. By the end, there were only 18. So was that an increase or a decrease in attendance? It was a decrease of people in the class. Okay, so remember, when it asks you to round to the nearest tenth, make sure you've got a tenths place. A lot of you rounded to the nearest whole number. You want to have a tenths place. Okay, so for number 11, what's the percent of error formula? I think you guys found it in 6.4. What is the percent of error formula? It's the amount of error divided by or over whatever the actual amount was that happened. For our final problem today, number 12, we're going to use this formula to help us. Sam estimated that 260 people would come to the play, but that wasn't actually how many people came. How many people came? 325. So we want to find out how much he was off, or what was his percent of error. So remember, we're always going to start with our formula, so go ahead and write it out for me. It's the amount of error divided by the actual amount. Does anyone think they might know how to find the amount of error that he had? Kaylee, what should I do?
Put 260 over 325 and then divide it.
No, we're not going to divide that yet. How do I figure out how far off he was? If he thought 260 would come, but 325 came, how do I find that error? What do you think?
Subtract.
We're going to subtract it. So take the bigger number, 325, and minus the smaller number, because that's going to tell me how many people he counted wrong or estimated wrong. Divided by the actual amount. How many people actually came to the play? 325. Okay, because it says right here there were 325 people actually there. Guys, what's 325 minus 260? 65. So he was off by 65 people. I need to take that and divide it by the actual amount of people that were there, which was 325. So go ahead and divide that for me. What's 65 divided by 325?
0.2.
0.2. Okay, now I want to turn that into a percentage, so what would that be as a percent?
20%.
20% is correct. So his percent of error was 20%. All right, so that's all that we're going to be doing review-wise today, and tonight there is no homework.